Hi, everybody. Welcome back. We are doing more practice with limiting reactants. So video 13, limiting reactants, and I am on homework sheet number 2. And just like number 1, I'm going to walk through some of it, walk through the setup, and then I'm going to release you to do some of it on your own. So I did already copy some of the problem down. So if you want to, I'm not sure right now if you're working from homework packets or printed sheets, but if you want to pause the video and copy this, if you're working on your own paper, you can go ahead and do that. For homework 2, we are going to be looking at Tums. And specifically, calcium carbonate is one of the active ingredients in Tums. And we're saying that you have a stomach ache due to 25 milliliters of excess stomach acid. The density of your stomach acid, or of stomach acid in general, is 1.8 grams per milliliter. And you are going to take a Tums tablet, which contains 25 grams of calcium carbonate, in order to try and neutralize this excess acid and get rid of your stomach ache. The chemical reaction for the calcium carbonate in the Tums reacting with the acid in your stomach is below. They react and form CO2, H2O, and then a calcium salt. Step 1, balance your chemical equation. So I just kind of eyeball it. 1 calcium, that's good. 1 carbon, that's good. 3 oxygens, that's good. 1 hydrogen, 2 hydrogens. So I need 2 here. That gives me 2 chlorines and 2 chlorines. So this is pretty straightforward. 2 HCl's and 1's for the rest. Now, again, just like in problem 1, we're going to be working from a table. So I always start with molar mass. After molar mass, we're going to calculate our limiting reactant using our reaction. And our initial masses allow us to calculate our ending values or our theoretical yields. All right, I can fill in my reaction. CaCO3 is going to react with 2 moles of the HCl to produce CO2. The rest of these are just 1s, water, and a calcium chloride salt. Now, I start my reaction with 25 grams of the calcium carbonate, and I want to pause 25 milliliters of hydrochloric acid. Milliliters is not a mass, so I actually am going to have to do a density calculation to figure out the initial mass for my HCl, since the value I was given is in milliliters, but I was given the density, so that's pretty easy. We'll need to know the molar masses. So for calcium carbonate, molar mass of CaCO3, 100 grams per mole. Molar mass of HCl, 36 grams per mole. CO2, that one's 44 grams per mole. Water, 18 grams per mole. And then calcium chloride, 111 grams per mole. So initial mass of HCl, again, I'm looking to calculate this value here. Take what I know, which I know I'm starting with 25 milliliters of HCl. Milliliters, the label needs to cancel. And using the density, I can go to grams of HCl. The density of HCl is 1.18 grams per milliliter. The 1.18 goes with the grams, and the 1 goes with the milliliters. So take 25 times 1.18, and you get a value of 29.5. Now, I only have 2 sig figs here, so that will actually round to 30 grams of HCl. So that's going to be my initial mass of HCl. 30 grams. From here, I now have both substances in grams. I can calculate my limiting reactant. For the limiting reactant, remember, you're going to need to do the calculation for both. So we're going to calculate it for both HCl and calcium carbonate. I'm going to start with HCl. Now, for the HCl, this is a rounded value. I'm going to keep doing what I said I would recommend. Start with the values in the problem. So I know that I start with 25 milliliters of HCl. From milliliters of HCl, I can go to grams of HCl using the density. From grams of HCl, I can go to moles of HCl using the molar mass. Molar mass of hydrochloric acid was 36 grams per mole. Plug that into a calculator. 25 times 1.18 divided by 36. I have 0.82 moles of HCl. To figure out my limiting reactant, I need to divide that by my coefficient. Now here you are going to see me start to kind of combine some steps. My coefficient is 2. Take that value, divide by 2. And my value for HCl is going to be 0.41. Do the same thing for your other reactant, which is the calcium carbonate. This time I start with grams, so this one will be more straightforward. I have 25 grams of calcium carbonate. From grams, I can go to moles using that molar mass bridge. So calcium carbonate has a molar mass of 100. 1 mole contains 100 grams. Okay, this is just a decimal slide. 25 divided by 100, 0.025 moles of calcium carbonate. Divide by the coefficient. Nothing out there. The coefficient is 1. Divide by 1. My value for calcium carbonate is 0.25, which means 0.25 is my smaller number. Calcium carbonate is my limiting reactant. So I can go up here and I can label that as my limiting, which means calcium carbonate is going to be the value that I take through the rest of the table. Since it's my limiting reactant, I know that my theoretical yield of calcium carbonate is 0 grams. Now, I'm going to ask you to calculate this value by yourself because I did it on our last homework sheet. I just want you to remember and just stick a little note in your brain when calculating it. Don't forget to do that last step of initial minus consumed. Then you'll calculate the amount of each product produced. So since I did an example for theoretical yield of a reactant last time, I'm going to do an example for theoretical yield of a product this time. So part C, we are going to be calculating theoretical yields. And we are going to we'll do CO2. All right, so start with what we know. I know that this is my limiting. So start off with 25 grams of my limiting calcium carbonate. From grams of calcium carbonate, I can go to moles of calcium carbonate using the molar mass, which I already put that up here, is 100. From moles of one substance, I can go to moles of another using the mole ratios. So moles of the calcium carbonate to, where am I going? CO2. And from moles of CO2, I can go to grams of CO2 using that molar mass. Now, coefficients. It's a 1 for calcium carbonate and a 1 for CO2. So just a couple ones there. Molar masses, the 1 goes with the mole, and the molar mass of CO2 is 44 grams in 1 mole. Type that into a calculator. 25 divide 100 times 44. I am going to produce an even, 11 grams of CO2. Oopsie. So that value's been calculated. I can plug that into my table. And then I want you guys to go ahead and finish the rest of this table. So go ahead. I want you to calculate the amount of HCl remaining, the amount of water produced, the amount of calcium carbonate produced. And then at the very end, I want you to answer. So this will kind of be a step D, a different one. I want you to answer the question and do the calculation for, I'll just throw it on the same paper. I got mine on the bottom. I want you to do the calculation that will answer the question. Oopsie. What is the minimum amount of Tums or calcium carbonate that you would need to take in order to use up or neutralize all the HCl, the excess HCl. So remember, this is where we talked about the 25 milliliters in your stomach. Now, to answer this question, what is the minimum amount of Tums? This one, a little bit different from our table. In order to calculate how much calcium carbonate you would need to use, start with the acid and figure out if I have 25 milliliters of acid, run an equation to figure out what grams of calcium carbonate would be used. So same type of question, just instead of using the limiting reactant, use the calcium carbonate and figure out what grams of HCl would be used up if all of that calcium carbonate was reacted with. But go ahead, I want you to finish the table and then answer this bottom question.